Alright, everybody, welcome back to part 3 of designing TikTok. So we're gonna go ahead and get started with some overview of what we did last time. We're gonna go over everything real quick, and then I'll give you some time to answer some questions. So let's see. Alright, so first requirement we get is upload a video that can be 15 seconds to a minute long, watch an endless amount of videos from any user, log in, sign up, follow other users, like a video, leave a comment, watch user profile, notifications, live streaming, and telemetry. For non-functional requirements, we've got low latency, so P50 of video consumption should be at 100 milliseconds. We got security, we got the code has to be maintainable, split into many pieces. We've also got security and global region availability of 99.9%. So that's what we've got here. We've done quite a bit of back of the envelope calculations, and these are going to be important. Probably in this or next episode of this recording, we're going to be tying back most of the systems back to these numbers, so we'll watch out for those. We talked about the query language that we will design for system availability and performance. So we will have an ability to read and parse logs and use those logs for canary and machine learning. So this will be pretty important later on. So now let's kind of walk through the overall design. So we have a user, which is an iOS application that downloads the link that's sent from the S3 bucket. We have a load balancer, and we have a CDN. So we'll dive into much more depth about those later on. We have our main application server. Right now we only have one API that maintains a stateless connection because the user ID is just passed as a parameter. And this video API calls UFGMLS, user feed generation machine learning service. The UFGMLS, how it works right now, it returns a link. If it's not in cache, it's going to get a link for the video real quick. And what it will do, we have a pre-caching set up that will proactively start pre-computing 10 links for user ID. So this is how our cache works. We do always check whenever a call comes from this API to this service if this user is reading cache. If not, return the link. Sorry about that. And then we will see how it goes further. Then we have storing and machine learning service. So when we store some data for logs, we persist it in message queues, since latency at this point forward is not important. We persist all the data we have in a message queue, and for retrieving a link, we have a 3-second timeout per service that will shut off the request if it didn't come from that far. For the database choice of the telemetry and parsing, we've had a NoSQL database with MongoDB and some machine learning, and that allowed us to easily scale a format like this. So our telemetry machine learning data looks kind of like this. It's very unstructured. So we have a video ID, the average watch time in seconds, like count, time to achieve, and this can be very much easily changed using our custom query language. And we have our operations going on. We kind of went over some examples of how one video ID we can do like on or user ID. So I don't want to go into too much depth on just a recap. So here we talked about how we use this for canary and how this would be beneficial to see errors and by metric. And here we talked about deployment, how we'll have a deployment that uses a non-CI/CD deployment structure. So every single commit would be staged before deploying to QA, then will be tested again in QA, and then slowly rolling out to production across many regions. We talked about the auto-scaling groups and how exactly we'll maintain scalability for our server nodes and what happens if the service goes down. Talked a little bit more about the lever suite on how we'll maintain very high scale later on as the numbers will become more important. So that's something we'll talk about. Um, Now we also talked about the actual database for the main application. So we talked about the SQL relational structure that has user ID, video table, comment table, S3 storage, and followers. We also had a quick recap on consistency and replication. So right now, what we'll do is that before we jump any further, we'll I'll answer any questions on things we've got so far, any concerns or comments, and after that we'll jump into the upload API. All right, take it away with your questions now.
Hey, for someone who's not familiar with system design, what are the most important aspects of your demonstration?
Yeah, that's a great question. I think that um, it's really not meant to be like a mock system design interview. What I'm going on right now, I feel like this is more kind of like in depth. Me trying to absorb as much knowledge as I have to see where my knowledge lacks. So I would eventually want every single person in the channel to kind of go through like this is more like an evaluation that we record these things and we can see where the person lies in terms of their system design. So once you do something for like 6 hours, you're allowed to basically go on any topic as you like, as deeply as you possibly can, and then we can evaluate where your knowledge lacks or where your knowledge is pretty strong. So for the system, to back to your question, I think for the system design actual interview, it's important to pace yourself and get as much as you can 45 minutes and listen carefully to what the interviewer wants you to work on, and make sure you don't you take the interview in the way that interests the interviewer. You know, there's so many concepts, you know, you can touch upon. You can talk much more about caching, persistence, latency, database choice, and it's very important to listen and carefully understand what exactly needs to be answered. So yeah, I hope that
Yeah.
answers your question.
So I wanna dig a little bit into some of the choices you made here,
Yeah,
right?
yeah,
So
absolutely.
one thing I did see is like the video feed API. The way that you formatted it is looks like HTTPS to me, like a get post sort of thing. Is how
Correct.
it looks like it's formatted. But you say there that you choose to use gRPC for low latency.
Yeah,
So
I'm absolutely glad that you asked this question. So the way how I set up my infrastructure is that we maintain our entire service in a virtual private cloud and a VPC. So the VPC, right, everything that is inside of VPC will be making the very quick gRPC call. So gRPC call here is made to from video API service to UFGMLS. That is
so it's
communicated
internal is
internal.
for
Yes,
J.
yes,
Okay,
internal.
and could you explain why JRPC is low latency and typically faster than an HTTP call?
Yeah, so instead of using JSON format as a response times, we use something called a protobuf, which delivers packets easily and takes less memory. And
Hmm.
that basically the biggest advantage of the gRPC. That's using
Cool,
protobufs instead of a JSON that is converted to binary.
cool. And then for your SQL database, it looks like you're asynchronously, that all your replicas are asynchronous and you have a single writer.
Yes. So the database choice was made with this consideration in mind, since
Mhm.
it is not important that we have the consistency is okay to be eventual, and the reason for that, if I upload a video and I try to request the video with the URL, it is okay if we don't receive anything because there can be really any videos present. It doesn't have to be specific video, so there can be a delay uh, for up to like 15, 20, 30 seconds, even a minute or even 5 minutes before the users can start actually seeing the video. So eventual consistency is totally fine. So the idea was here that we will use primary to secondary database to maintain since our application is very read heavy and we want to achieve low latency and consistency is not important. I decided that um, primary to secondary with replication, asynchronous
Oh,
replication would be the best choice here.
cool. Um, so I think typically I've never seen any real systems that do full asynchronous replication. There's always at least one or two that are synchronous, and so those are used for failovers
Mm-hmm.
when the primary fails. And so I just like to mention that. I've never seen a full asynchronous replication in real systems.
Yeah, so the goal, yeah, that's a good point. I think that we kind of mentioned here. No, that's a really good point. I feel like something that I was not really considering here is the way how the algorithm would work to, in case of the primary fails. I was thinking that I would need to come up with an algorithm to determine a leader. So I was thinking about like a manual leader pointing algorithm. So for that, I do think that I would need to have at least one secondary node that would be not in async but would be in synchronous replication. Is that what you're referring to?
Um, Well, I'm talking about, yeah, if if you have multiple sort of synchronous, right, then
Mm-hmm.
those replicas that are synchronous can hold sort of can go through a consensus algorithm, which usually takes a little bit of time. Usually it's pretty slow, but it's something that you have to do. But then they pick a leader out of the sync, the replicas that are in sync, and they
Right.
choose to be the leader, right?
Right.
And the reason why you have a few is because the consensus algorithm takes about two times the total trip time between all instances. So you want to bind it to be a small set of the total set of actual replicas that you have.
Mm-hmm. Mm-hmm.
Yeah,
So we need to add secondary replicas that
yeah.
can potentially.
But yeah, only like a few.
Mm-hmm. Is there like is this the idea that we have to have a quotum? Basically, that we have to maintain like a certain number of nodes, like n divided by two minus one, some sort of
No,
formula.
no, no. It's not a quorum.
For
It's not a
okay,
quorum. You're going through a consensus algorithm, right?
mm-hmm.
And you're picking a single leader.
Right.
Quorums are for like if you have multiple leaders, right? Multiple writers.
Yes, I see. So in this games, just to be again on the same page. We will have the right flow that has the primary and then has the sync to the secondary, which is going to be synchronous sync to the
Yes.
secondary, and it's going to be not literally one secondary. It's going to be a smaller cluster than
Yes.
the main replication. So, um, would you be okay if I just said that this thing happens across many regions, or do you want to go more kind of in depth into saying how exactly I'm going to be replicating across many
Uh,
regions?
I wouldn't dig. I mean, I would want to hear more about, the other stuff you do, so I wouldn't dig too much, but I just
Okay.
wanted to mention that like there's no true fully asynchronous replication.
Yeah, that's a really good point. And something that like I also wanted to really consider here is that before we actually do any writing, and this is kind of like designing that flow, I was thinking about putting like an SQS or SNS in front of the database so we can have some sort of like higher persistence for the videos that we upload in case something goes wrong. Or then the other thing is we'll just let the user fail uploading the video since like again like
So which one? SNS or SQS or Kinesis?
yeah, I was thinking like a simple queue service, right? So SQS
Hmm.
would be actually better since there's not like really notification that has to go from it.
Hmm.
We're not really we're just gonna query the the actual file before before I upload it to the S3. So I guess this
Hmm.
wouldn't really even talk to this flow as much. But kind of
Hmm.
the ideas I was also thinking is that if user is uploading the video and something goes wrong with the server, we just fail the request and don't really persist it. Is that
Hmm.
something you would say is acceptable?
Yeah, so that is a very well and tried true technique for increasing write through throughput.
Mm-hmm.
But as an interviewer, I'd like to hear you talk about choosing either a log-based message broker or a memory-based message broker, right? They have different uses, right? And for when you want to increase write consistency and write throughput, you want to use a log-based because that actually persists everything to disk. Well, if it's just in memory, you can lose writes.
So you would say that instead of using like a simple SQL, you need to pick something more fancier like Kafka?
Well, you'd have to. I believe SQS is durable. I'm not sure if Kinesis is.
Mm-hmm.
Kafka is durable. SQS is durable. Kinesis isn't. RabbitMQ, something like that, is in memory. So I just want to hear you say like, oh, I'm going to be using a log-based broker for this because I want to make sure that all my writes are durable.
And log-based broker just basically means that I'll persist them somewhere before I'll persist the data before I write it to the database. Is that what it's referring
Yeah.
to?
Yep. Yep. You're going to persist it to disk, and it's append only. So it's very, very high write throughput, and you get full replayability of events.
But in this case, I'm more kind of thinking like if we go like back to the like thinking about the like sequence diagram. So what happens? For example, we have the user here. And for this is the sequence diagram for the write flow. So the user um, attempts to upload the video, and the user will be talking to the upload server. So that would be, I think, directly to the S3. So in case of an error, we're not going to be persisting anything. We're just going to be returning 500 to the user, and then the user will be basically denied anything. So this is going to be upload server. This is going to be the user.
Mhm.
So this is kind of what I'm thinking, right? So in case we have an error, so the flow goes down this way, and here this is going to be the error case. What will happen if the error did not happen is that we'll go to the S3. So there is going to be a proxy between the actual S3 bucket, and we're not going to be
Yeah,
maintaining.
of course.
Yeah, and then this is our S3. We'll write S3. So S3 bucket. What will happen here is that on, I guess something that I also should mention is that the error case can only happen after we attempt to write this to an S3. So the actual, I guess, sequence would kind of go like this. Let me drag this out a little. So this will be this thing right here, and then so we'll first get the attempt to upload the video. We start we'll open up the connection with an S3 bucket, and what will happen next. So in case there is some error appending this to S3, what will happen is that we'll return back to our upload server saying that there is an error. So it's a little tight right here. Let me move this down a little bit. So this is going to be an error, and what we'll do is we'll be basically just return an error to the user, and we're not going to be trying to there's basically no retry for the case of error. And the user will just get like in the UI will get like a error message saying please try again at a later time. In case we verify that this is a good upload, we'll return a success message. We'll return like a 200 OK or any success message really here. And what will happen here is that we'll return back to the user in our success response saying like 200 OK, and then we'll return the signed S3 URL to the video, which is going to be converted in the signed S3 URL is going to be then used to identify the internal system locator for this video. So what I'm thinking here is that this signed S3 URL, maybe it actually would be even better that signed S3 URL is not going to be returned to the mobile app. Instead, the signed S3 URL will be returned to the upload server, and then the upload server will obviously add this signed S3 URL in the video table. We have this URL here, and then we'll create the new entry in our database. So this is kind of reference to our previous SQL database. So once we have this S3 URL, what will happen? We have this thing right here, and let me just make a little bit more space. We'll have the SQL here. So once we have this, let's do. We'll now try to create a new entry. In video table. And is everything that I'm saying kind of makes sense so far?
Yeah.
Jason, what do you say?
Yeah, it makes sense to me.
Cool. Alright, so struggling a little bit with this diagram. So we'll try to create a new entry in the database. We'll return it. And this is actually not going to go to the user anymore. This is going to just go to the upload server. And now we're going to finally return to the user plus internal URL link. So in this case, it's going to be like TikTok, like app, you know, whatever the Apple URL is that, and then video, and then the video ID. And then once the user clicks on this link, so for example, I'm not sure how exactly it works, but maybe it's prefixed with Apple, whatever makes the link basically, whenever this link is opened on the mobile client, on the mobile phone, instead of going to the web browser or anything like that, we'll directly open this thing in the mobile app. So this is the whole idea why we would need to, the whole kind of process of how I'm thinking that the right flow would be.
Definitely curious. Shouldn't some pre-processing be done to the video?
Oh, you're thinking like making sure that the video doesn't have any bad content in it, anything like that?
Well, I was also thinking encoding.
Right, so yeah, you're totally right. So we'll probably need to convert the video somewhere here. So let me think about that. That's a good point though. So encoding, I guess what exactly do we mean by encoding? So I'm not gonna try and guess right now.
Yeah, I mean, the file is going to be maybe not the right file type for displaying to the user's phone. It might be really big. You might want to compress it, stuff like that.
Right. Yeah, that's a really good idea. I think that before we actually go to S3, so I think we'll let me think about that. So yeah, that's a really good idea to add like a compression service here. So this, yeah, this some things we'll do. It's encoding, checking for copyright, checking for copyright material, checking for any inappropriate content, do auto processing, and this is going to be also like a big service that's going to be like deployed, I guess also across many nodes, because this is going to be very computationally extensive. So I'm thinking that we can even talk about some hosts that I have in mind for these services, if you think that would be a good valuable thing to add here as well. So we attempt to upload the video. Now we attempt, instead of I guess saying attempt to upload here, I would say attempt process the video using compression service, so CS. And what we'll do in case of an error, now we're gonna have kind of many more error cases. So in this case, if the thing errors during the compression service, we'll return 500 immediately. Or it's also possible that the thing goes okay. We were able to compress and verify the video, so we'll make a request to S3 bucket here. this is telling us, like, for example, 200, okay, the video is clear to be stored, and then what will happen is that this can potentially also have an error case. So video was error during storage. So we'll return an error response. In this case, this thing will also return an error response, and that will eventually convert S3 error case, and that will also return it as 500. In case of a success, this thing right here will return directly. Not
So
directly.
yeah, there seems to be like a lot of potential error cases as everything is sort of done synchronously here, right? Is there a way maybe we can reduce the amount of error cases?
Right. Yeah, let me think about that. So what we can do to reduce that? Maybe we can hold off to the errors before we return anything, right? So maybe instead of returning, maybe like when we get the error case here, we don't have to return it right away. We can just store. Yeah, this error case potentially can actually be eliminated. And this can be like a compression S3 error case, and since this thing is actually very can have actually quite a bit of throughput, I think that we may as well need to like have a queue uh, that needs to store all the videos before they can be sent for compression and SQ. So I think actually I might need to insert two queues into here. So yeah, that's definitely very interesting how I started this and I missed so many things. So how does the queue sound to you, first of all?
I like the idea of the queue, but are you just gonna put the video onto the queue?
So yeah, what I'm thinking here is that when I have my upload service, um, what can potentially happen is that the compression service can be full,
Mhm.
and what will happen is that I can overwhelm my compression service with a video, with like amount of requests that I make to it, and it can potentially die. So I'm
Okay.
thinking that before I send anything to the compression service, it will be stored in SQS, like a persistent queue,
So
and
what's gonna be stored in SQS? The video?
yeah, the raw video.
That's a no-no. You can't store it. That's way too big of a file to store on SQS.
Even if it's
Maybe you can put the video onto S3 and then put a video ID on SQS. That could work, but um, SQS or any sort of log-based broker is meant for small sort of
hmm,
text, not even images.
I see. So you're thinking that we should like have a separate like S3 storage for like raw videos, and then the separate
Yep.
S3 for the processed ones.
Yep.
Oh, that's a really interesting idea. So I guess before we like move forward, is everybody kind of here on the same page about what is wrong with this and how this has to be optimized? Cool. I'll take this as a yes. So I'll just gonna go ahead and try to expand the service. So we'll basically move this a little bit to here. And just to be clear, right? We don't have to have any queue. Whenever somebody uploads something to the server, they will upload it straight to the S3. So since it's like an external server, we don't really need to worry about if it can handle or cannot handle the load, right? Jason?
Yeah, I'm fine with that. Like if you say, yeah, S3 is pretty much infinitely scalable, I wouldn't be worried about that.
Yeah. Okay. So we'll have our raw S3 bucket, and so what will happen here is that we'll try uh, attempt to store raw videos. So we'll attempt to store raw videos in this bucket, and here I guess this is kind of going to be on the side because this is not going to have any actual and now, as I mentioned before, we will have the queue, So this is going to be the SQSQ, but as you mentioned that the SQSQ will store only video, signed video URLs from S3. This is this is kind of what I'm thinking. So the first thing that will happen is that we'll try to process the video using okay, upload. Now this doesn't make sense. Now upload to the raw S3 bucket, and let me make this a little bigger. So this thing will try and upload to the raw S3 bucket, and this thing will return S3 URL. Now the thing what will happen after this is that we will have an error go in here, and what this thing will do is it will store the video ID. So store URLs, raw S3 URLs in the SQS. Right, so we'll basically persist all the videos that we still need to store, so we don't overwhelm the compression service. So now what will happen is that whenever the compression service is ready, it will start polling. It will start polling from the queue. So compression service will start polling from SQS, and now the compression service will try to do the compression checking, encoding and everything like that, and only then it's going to store it in the S3. So if S3 returns an error, the error is going to be propagated back to the compression service, and then in case of a 200 OK response, let me just make it a little clearer, compression writes to S3. If there's error during staging, we'll return that, or we'll return write OK response. So now what will happen here, so in case there is a compression S3 error case, so basically if there's any errors that happen during this entire process, we'll have this error basically propagated back to the upload server right here, and then this will finally just return 1500. So we're not going to try and retry to do anything like that. So now what would happen?
Wait, why? Why do we want to propagate the error from all the way in the compression service back to the user?
Well, because we would need to let the user know that their video was either inappropriate or was not able to process at this time.
Do they need to be? Does that need to be done synchronously?
No, it doesn't need to be done synchronously. That's a good point.
Yeah. Once we store the S3 URL onto the queue, I think right after that we can return OK to the user, because then it's persistent and we can retry everything. You can drive it to completion once it's stored on SQS.
Yes, I think I agree with you. The only thing I'm thinking here is that what if the video will not be able to complete, not for a reason because the system is down, but because there's something wrong here. So should we think about like an SNS that will not like send a notification to the user that's saying that the video is not okay? Is that something you would consider?
Yeah, that's something I would consider.
Okay, then you're completely right. I think that there is
So if you think about it, the user uploads the video, right? And then they have to wait for how long to get it? Oh, this is inappropriate, right? Like compression could take a while.
yeah, because we store into the queue and this takes a while. So we don't want the user to be stuck, waiting for the response from this 500. So I'll make a little bit more space here. But I guess if there is an error uploading this to the first S3 or SQS,
Yeah.
are you still okay with the 500?
Yeah. That's kind of you kind of have to do that, right? If it never got uploaded raw, then it never got persisted.
Right. So let me kind of make much more space. I didn't really expect how much more space I would need here. So you can see that my actual diagram was not very scalable. Uh, okay.
I'm not trying to like knit so much. I'm
No,
just
no, bro,
like
this is amazing. I feel like yesterday's session, I definitely sounded much more smart because nobody was really making this type of comments. But now I feel like I'm actually learning something.
yeah, like hopefully like you'll be able to like use this information for your TikTok interview, you know?
Yeah.
I'm just trying
No,
to
this
help,
is
you know?
this is really amazing. I absolutely loved it. Thank you so much, Jason, for joining. I hope it's helpful for you too. You know, I don't.
Yeah, of course, of course.
So alright, so let's think about it, right? So we have the store raw S3 raw S3 URL and the SQS, right? So in case something goes wrong, in case there's an error case, I don't want to. Well, I will kind of find out about an error sooner, right? Because if the S3 URL is never returned from S3, that's kind of another error case, right? Because there's thing that can happen if the S3 URL is not returned, right? So S3 is down, so S3
Yeah.
is down, error 500. Or the SQS can be also down, so we need to think about that as well.
Yeah.
So here, what will happen is that we'll have error case immediately propagated back to the user, show them 500. So in the
But
UI,
the reason why I think this is acceptable is because both S3 and SQS are very highly available services. You know, they have like many nines to them. So
yeah, that yeah, I agree. I think I'm not sure if S3 actually tries to do some re-uploading if it fails. I would need to really dig more into that to see how S3 works under the hood. But if we were like have a ability to customize, I probably would set the setting of S3 to not retry at this point, not retry auto re-upload, right? Because we want to kind of like let the user know we failed and don't really worry too much about it and just return them a 500 and let them know to try again later. And since you mentioned it's very super highly available, I don't really think that
yeah.
this is too important. There is too many things to worry about. Much more interesting case is that once we pass this error case, we'll on in case it does go through, in case we storage in storage store to SQS okay. So that's going to be the end of the synchronous flow. Everything here in this territory is going to be asynchronous flow. I'm gonna kind of mark it like this, so it's very clear. So this is the async flow. I know I'm supposed to also like draw, like the error flow with a like proper sequence diagram, but still, I'm not sure how exactly to do that. So I'm gonna kind of do my pseudo sequence diagram. Okay, so store SQS. Okay, so in this once this happens, we'll return uh, a success message. So we're returning 200. Okay, check back soon. So we're letting them know that the video is gone for uploading, and we'll basically need to think about when that they should be notified uh, when this thing happens. Okay, so oh, by the way, I wanted to clarify: is this okay? Is this clear why we use the HTTPS here? The rest here, because this is outside the VPC. This is going to be the mobile client talking to our backend. So HTTP over REST. Is that clear?
Yeah.
Cool.
Good to me.
Cool. So now this kind of gets a little bit more complicated. So error during storage. Now here I'm going to change my strategy a little bit. Instead of I'm pretty sure you can configure S3 to retry. Don't quote me on this, but I'm pretty sure if like in case something happens to the bucket when you're trying to stored, you have an option to retry. So what I'm thinking is that you can attempt to retry, and this is going to be another flow during the error case that will attempt to retry. And since the system is highly available, I think it's with some exponential backoff it eventually will write. Is this assumption okay with you?
Oh yeah. The SDK automatically retries like 3 times.
Mm-hmm. Yeah. Okay, so at this point we get write okay. But now we can have an error case where video was not appropriate. So now at this point, we'll have two responses. So instead of a compression code, we'll send a notification. So now we would need an SNS. And I'm choosing SNS because I want to have persistent notifications. So now it's going to be an SNS, simple notification service. And this SNS will do SNS, and it will store either it will store the video ID. Well, at this point we actually don't have a video ID, right? Because we didn't write anything to the to our table. It will just return status, and it's going to be status okay or not okay. It's going to return the link, which is going to be nullable. It can actually return null as link, and then it's going to return error code, and it's going to be a reference to an error code table, which will basically contain like, oh, this video contained a copyrighted material. You know, like for example, like error code like 206 would map to like inappropriate material, 205 would map to copywriting. So stuff like this. So this error code will be provided from the compression service, and then we'll normalize the error code. We'll hydrate it to a more like human readable format, kind of in the upload service. So something I can think about is that we'll potentially need I guess what I'm thinking here is that I'm not sure who should be polling from the SNS. I'm thinking either I should create like another service that will do like SNS polling and then talking back to the upload service, and then making the decision what to return to the user. So I'm thinking that would that be okay if we have like a separate microservice talking to the SNS and then writing to the DB and returning the notification to the user, or would you prefer like that to be done like with the upload service we do have? Like, do you see the value of adding like another service in between the user upload service and the SNS?
Yeah, that sounds fine to me.
Cool. Yeah. So what I think here, what I'll do is that we this day again is like very not like normalized. It's very like not really human readable. So the idea here behind the microservice is that the microservice will be able to hydrate this data. So it will do data hydration, and it will complete the write flow, and then Fred is going to send a notification. So here, I guess this is going to be a little smaller. So now how this thing will work. So this thing would poll from SNS. It will listen for a new video to be available. Now in case of an okay, in case this is okay, so what we can do is that we can video done. Okay. So now this would go ahead and create a new entry in the video table, and we'll complete it, and then we'll return. But at this point we don't have a connection with the user anymore. So at this point, once the video is created, we'll probably need to have another SNS. So here we'll feed another notification service, with more appropriate. Here, this is going to be a very user close.
Is
Uh-huh.
is there a reason why you don't write to the video table from the compression service?
Do you mean from this flow directly?
Yeah. Yep.
Hmm. No, that's a good idea. I think if we write directly from the compression service, we can actually eliminate this step, and probably even eliminate this queue. The notification service here. So what can happen here is that um, instead of writing from here, I will just drag this down, and this will go back here, and then create video in the video table, and this thing will go right like this. And now this thing will move here. So what I'm thinking now is that we actually don't have to maintain any connection with the thing anymore. So what will happen is that we'll have direct response notification back to the user. So whenever we can, we'll just return back to it. And if we need to hydrate something from here, we will. This is already going to be probably internal link. If we need to hydrate something, we can always have another service that will do some mapping, take like raw code, like a raw error code, and then map it to. Unfortunately, this video violates blah blah blah.
Yeah. I mean, I think it's fine to hydrate on the client side, to be honest.
Mm-hmm. So hydrating directly from the user mobile phone.
Yep.
So we basically, instead of calling it from here, once we receive a notification, so this is a case of um,
Yeah, because like the app will probably have, 42 and then it'll map it to the error message, right?
mm-hmm. Yeah, that's totally fine with me. I don't think we really need another service for that. But yeah, so let me kind of walk again, I guess for everybody here, to see exactly how the flow would work, and we can talk about how available it is and how persistent. So the user will attempt to upload the video from their phone um, after they recorded it, or after they provided the already recorded video. So what we'll do, we'll upload the raw video to the S3 bucket, and if it if it uploads okay, we're gonna return an S3 URL or an error. So if S3 is down, return S3 error, or I guess to say error. We're not gonna try and retry more than the regular time. So at this point, the persistence is not guaranteed. Um, we'll just return that S3 is down, we'll return error 500 to the user, and the video is not accepted. If this doesn't happen, in case of a good case, we'll store the raw S3 URL and not the actual video. We'll store it in the SQS, and this SQS will just contain the links to the video from this S3 bucket. So now, whenever the compression service is ready and has more capacity to process the videos, it will start doing video encoding, checking for copyright, checking for any inappropriate content, doing other processing, and then the compression service, once the video is verified and compressed, it will write to the main S3 bucket that we outlined in our database design. So what will happen then is that we'll have if there is an error during storage, in this case, we'll actually eliminate this case, because now we'll have the automatic retry. It will keep doing this until we will get an OK. Now, as soon as we get right OK, we're going to create a new entry in the video table in our SQL database, and then we'll have the 200 OK success signed URL to the video. So what will happen after we have successfully created the entry? We'll populate our SNS notification service with notification for the mobile phone that their video is ready and ready to be posted. We return link, status okay or not okay, or the error code. And as soon as notification received, we'll the hydrate the message saying either the video is okay, posted, not posted, and if it's posted, there's going to be a link to it, or a link to the message that explains why it was not accepted in more detail. All right, does that sound okay with you so far?
I'm happy with that flow.
Okay, now anybody from chat has any questions? And by the way, I cannot see the chat. If somebody's typing, please read it out to me.
There were no questions in chat other than if the Excalibur was shared, but I think maybe afterwards.
I think the Excalibur was shared. So
Where?
I think it's in the invite.
Ah,
Yeah. So yeah, I think there's a link in the invite. Cool. But overall, this is gonna be the flow of the write. So now the next big thing is going to be the live streaming. So now we can move forward to that portion if that's all right with you. Jason, if that's all right with you, I guess. Since you're
Sorry.
kind of since you're kind of the
I'm
most
okay.
active.
I'm okay with it. Yeah.
All right. So here, Jason, I actually would need quite a little bit more help from you. I'm here definitely not an expert. So if you wanna have more like kind of help me out a little bit, I'll totally cool with that. So if you can just
Sure.
like,
is some
uh-huh.
mod can take admin off of server deafen?
Oh yeah, somebody, but he should be able to do it himself.
Oh, yeah, he should. I don't know. I just saw it was server deafen. I thought.
Yeah. Let's see. All right. Okay. So now let's talk about more about the streaming. So all right, streaming live video. So let's kind of outline maybe some just concepts, Jason, that will kind of need to be present. So when a user starts streaming, a notification will appear to all the followers. Um, we need to have no more than 15-second delay. We need to stream video and audio in high quality. That can be adjusted for by the end user. So we want to make sure that the video bitrate and the quality can be adjusted for like lower connections. So yeah, I guess that's actually like a big step that this encoding thing does, because like some videos will need to be maybe stored, you know how the images stores sometimes stored in like multiple resolutions, you know, like the to like allow for the faster load. I guess that's something I also should have mentioned. We can store multiple videos in multiple resolutions, and depending on the user's internet connection, we can choose what type of video they will be downloading from the service. But that's for the read flow actually more so. But here, so Jason, do you have like any idea really how the streaming works?
I don't have too much of an idea, but I mean, if we are streaming video, right?
Mm-hmm.
Wait, upload is for the upload to the stream or upload just for a TikTok video?
Just a TikTok video, yeah.
Oh, okay. So yeah, I imagine that the flow would be pretty similar for, I mean, the upload side, but you're going to be chunking the video for sure.
Mm-hmm.
You're gonna chunk it by like maybe 10 megabytes, 20 megabytes, so that you can constantly serve that to the users that are watching. That
Mm-hmm. So kind of like a producer consumer kind of flow. So we have one producer that's gonna write. So for example, let me kind of start with a like high level overview. So we have like the user, the streaming user. Well, let's kind of go ahead and like start with the first thing, right? So we kind of want to notify everybody once this user starts streaming. So when we talked about in our SQL, um, in SQL design, we were thinking that let's see, we're thinking that what we can do is that we can have like a property in the user table that says whether the user is streaming to be like a boolean variable, and then we'll have the another SQL table that has like user to follower, two column that basically says like if this user is following another user. So can you think about like a more optimal approach that would allow us to like very quickly to track? Oh yeah, another thing we talked about is like we can store followers in the user table. It's like a computed SQL query, so we can kind of have like cache, and this cache updates on every single time somebody subscribes to someone. But what I'm thinking here is like if one user has like a lot of followers, this becomes like a little bit inefficient. And like wanted to think like I think in DDIA there was like a really good example how Twitter maintains the tweets from people who have
Mhm.
like a lot of subscribers. So I was thinking, do you like really see a way how we can like improve this current situation for notifications?
Uh, sorry. Let me think of it.
Yeah, sorry, that's a hard question, but yeah, to summarize, I guess here, like what we've got so far, we have a streaming set as boolean to indicates if a user is streaming currently or not, streaming or not. We've got followers table that has a user follower structure that basically what that kind of entails is like if it basically just says if user follows the follower and they're both from the same table. Now what we've got, the third thing we've got is we have the stream ID is a link to some sort. We don't know what that will be yet. And the fourth thing we got is just we got a followers as a computed SQL query um, that would kind of maintain like get all the followers in there. So
Oh, sorry. I think how I did it was for popular users. They did a poll-based approach. So people with like less than, let's say, 300 followers, um, every time a user is streaming, the user will push that change, and that change will propagate to all the followers. But then for popular people with like, I don't know, 10,000 followers, follower will know that user is popular. So when they check, they will pull it instead.
and so how frequent does the polling need to happen?
No, 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 not pull, pull, pull. They will pull.
Mm-hmm. But how frequently would they do that?
Mm. Well, I remember with Twitter, it's when they open the app, they pull the information. I guess if you're checking if the person's still streaming, you would have to pull on some frequency, I guess. And it would have to cache out a lot because it's going to be hit quite a bit.
Mm-hmm. But what are you thinking about the idea of like maintaining a variable boolean that has like if the user is streaming? Is that the design you kind of really have in mind for this, or you're thinking about like a completely separate like table that's gonna have like user ID for every single user that is currently streaming? Assuming we're not
Oh,
gonna have like a lot of users that do stream, right? It's gonna be like a very like small subset of creators that do stream. So do you think like it makes sense to maybe abstract away the streaming thing and just make the user as the primary maybe like secondary key on the streaming table and just see like basically a list of all users that the stream?
yeah, that sounds good to me.
Okay, so I guess let's go ahead and kind of like start with that, and we can like think about how exactly we can make this work. As of right now, like I would really need to think about exactly how pushing and polling works, because Yeah, because it's going to be quite challenging. So for every single user, we're making a lot of requests to the database. So in this version of the app, we have like 100 million users, and if we just aimlessly poll for every single user, that is very we need to do like a lot of caching to see if this user is famous. So potentially, if we don't have a lot of famous users in in the in the system, we can potentially get away with not too much computational work since we can often cache it, but still I feel like it's a little challenging here. So this is kind of something I'm thinking, right? So we'll have a streaming table, and we'll have a what we'll do here is that we'll have primary key is going to be a stream ID, right? So it's going to reference. Is that alright with you if I actually don't want to have like a stream like reference this table? I'll kind of have two of them, right? But they kind of want to serve a different purpose. So one streaming table would contain the actual information about the stream, and the other like streaming table that would contain information about all ongoing streams right now. Is that sound to you?
Why don't you call one of them like streaming metadata, right?
Yeah.
Or like live stream, like the most popular streams, because you want something for like if you're serving it local, right? You're gonna want like a cache and then like the actual database, right? So you want something that like you only should hit your database when the cache is missed.
Right. Yeah. That's kind of what I'm thinking. I'm just really debating whether or not I should just like not have the stream metadata, like not have two streaming like SQL tables at all. I should just have like one, and then basically everybody who starts streaming, I record them in maybe some sort of cache that would just basically maybe some like smaller like quicker access type of database, since even if we have like 100 million active users, I'm assuming only like 0.001% of them will stream at a time. So if we just keep the record of everybody who's streaming in cache, we can potentially get away with having like 25 gigabytes of cache. Is that something that you guys sound to you?
So are you talking about right now for your cache like server? Or are you talking right now just for like your general database?
So yeah, so something that I'm thinking is that I will get rid of even the well, I'll get rid of the streaming table. I'll keep the stream metadata table, and as soon as the user is set to be streaming, we'll create a new entry in the stream metadata, and we'll keep the record of the streaming person in cache. So what we'll do is that we'll have a
Why do you have to persist the is streaming yes or no to disk anyways? Like
well
I don't know.
because we'll because later I think that would be useful to check if how often do they stream. Is that
Aggregating for metadata
well actually no, that's not
for
important.
like
So I guess let me ask you this: why do you think it's not important to persist, like if the person is currently streaming or not? Like in case your cache dies, right? In case your cache dies and now you don't have any users who are streaming, you would kind of have a way to go back to every single user and check if they're streaming or not. But that seems like very inefficient, right? So we would need to basically have some sort of persistence to determine if the user is currently streaming or not.
I'm just thinking it's just a lot cheaper to just use an in-memory database like Redis for this. You know, like let's say worst case scenario, it crashes, right? The user looks like they're offline when they're actually streaming. I don't think that's the end of the world.
And what is the sum availability? Yeah, then go ahead.
I'm not saying anything. You go.
No, no, I was just thinking. Yeah, I was just gonna say like, would we be able? We still have the stream metadata table, right? Would we be able to maybe store a beginning and end timestamp, like a begin timestamp and then the end timestamp, and then we can since this is
I
an
mean,
end.
you could store that on the client's end. right? And when the client makes a connection again, you can just start from there. Does that make sense?
But what if the client fails? What if the person just closes their app?
I would not trust storing anything on the client end.
Yeah.
I mean, like, no, I mean, you can store it additionally on the client end too, right? Like, you can have a check, right?
Well, once we're gonna get to streaming, we will basically maintain some sort of like connection, stateful connection with a server that's going to be uploading the things, right? So we'll technically know everybody who's streaming right now because the way how streaming will work is that some we'll have some connection to the server, right? So this way, right, we'll have the streaming user, and what will happen is that the streaming user has to be connected somewhere. So I'm thinking it has to be like has to be like Kafka, for example, right? We write the bits, the let's say the 5 to 10 megabyte bits, and then we'll have this is our producer, and then we'll have a lot of consumers here. So we'll have a lot of consumers, which is going to be the viewers. And what we can technically do is that we will basically know that if somebody is writing to this, um, let's say for example this is Kafka, right? We'll know that this is something that this user is streaming since it's technically producer here. My concern here is that you mentioned that the persistent queue storages, which Kafka technically is one of them, do you think it would be able to handle like a 5 to 10 megabyte videos, or do you think we would not be able to like stream it like that?
I've never heard of that pattern. Maybe it works. I'm not too sure.
So would I again need to upload this chunk to the S3 and then let the piece it together on the client side?
I think that's okay, right? Chunk it into really small chunks.
So are you asking if Kafka can just handle the video streaming process itself?
Well, something that I'm thinking is that we'll basically the way how we'll deliver is that we'll um, upload very small pieces of video. We'll probably upload this to another service like a blob storage like S3, and then what happen is that stream we'll have the links in Kafka and we'll make the client basically download this small bits and pieces from the S3 to the client's phone. So if that kind of makes sense to you.
I don't know. I don't know if that's really the use case for Kafka. Like, I know Flink would be better for that, like Apache Flink.
Mm-hmm. So I guess
But you can definitely use Kafka for like events during the streaming, like liking, click, any of that type of interaction.
Mm-hmm. So what is I guess the difference between like what is Apache Flink I guess compared to Kafka?
Flink is
It's
the
more
consumer of Kafka. It's for computing.
And I guess what type of computation will really going on here, right? We have some bits and pieces of the video, and we need to get them across to the viewers in a very low latency format.
Mm-hmm. Yeah, I think that chunking it very small and uploading it to S3, S3 will handle the global replication, and each user knows which chunk to download, right?
Mm-hmm. So I still okay with uploading this to Kafka, and then Kafka will contain the. So something that I guess will happen is that we'll have many users streaming to Kafka, and that's going to be obviously quite a bit of nodes of Kafka here deployed as well. But something we can store is like um, user ID, and then we can store like AWS link to the actual
If
link.
you if you need to scale Kafka, you can always shard Kafka as well.
Okay. Yeah. I think that's fine. So what I'm thinking is that it will have like S3 link, and should we maintain like some sort of ordering? So we should like number it like link, like link piece or like link ID, that will have like, so we can have whenever the users will receive the link and will receive the number, um, they will be able to piece it together on the client side in case there is some sort of like buffering that's going on. So for example, there is potentially can happen that the link like 120 arrives before 119, and then the client side can piece the links together and then download it from S3. Is this kind of like sound to you?
Yeah, keep going.
Yeah, I guess what I'm thinking here is that this is going to be practically our users here. There's going to be like a lot more of them, so just demonstrating that like this. And here what will happen is that we'll have the logic will kind of go like this. It will um, the client would have a record of what they're watching, so they have they're going to, once they're going to be in maintaining connection with Kafka, they will know the user ID they need to poll for. So they have the already know. So they already know the user ID this whose stream they're watching. And what also the client already knows is last received link ID. So what the buffer will do is that it will wait for the last received ID +1. So it will put a new link, and then it will start downloading this piece from S3. And as soon as, like, let's say the client stops watching the stream, the client no longer polls from Kafka. So that's kind of like that 1,000 feet overview of like what happened, and this is going to be the.
So I do want to push you on one thing. So like, um, let's say the user's phone is kind of slow, right? Right.
Mm-hmm.
Do they really want to just get and when you're streaming, right, and your user phone, your network connection is slow, you received one chunk,
Mm-hmm.
right? But then like maybe 10 seconds pass and the person's actually like further ahead in the stream than you are, right?
Mm-hmm.
Wouldn't it be better to jump ahead to the current time?
Yeah, I think that's a good point. I was thinking like we can have TTL of 10 seconds. So and the way we can configure is that this link URL is going to be the timestamp since the video started. Can somebody mute themselves? I can hear myself in your mic. So we'll have the link ID. All right, who's doing this? Can you guys mute him, please? So what we'll do is that we'll have the link ID that's going to be the seconds received since the stream started. So for example, the link ID of 10-second piece or like whatever the chunk is going to begin with this. And if we'll check if the link that we just received is expired with the TTL of 10, we'll basically drop waiting and we'll just get whatever we can. But but again, like if we have somebody with a low connection, one thing I can add here is that we will have to maintain some sort of encoding here as well. And the logic is going to be very similar to, what we did here. But the point is that I kind of want to consider that we can have different versions of the video. We can have the version in the HD, version in like SD resolution, and then version in like low resolution. And we will let the client figure out which version they would like to poll. So we can actually return not one AWS link, we can actually return multiple. We can do HD, we can do SD, and we can return more than one link. That's totally fine. And have kind of the client like figure out which one works best for them.
So have you heard of edge computing before?
No, actually I haven't.
So that's the idea of bringing whatever is producing the video to very, very close to the consumers, right? So like a CDN, right? That's sort of edge computing, right? And we want really low latency for streams, so maybe that could be useful here.
Yeah, let me look into it. Maybe we can kind of say like think into. So can you just like make like a high level overview of like how exactly this works? So is like the streaming phone acts like as a server, and then the users will maintain a connection with the server, or
No, basically, it's nothing that complex, right? It's when when the streamer uploads a video, right? A s- It's a Twitch has something special. It's a little different than the CDN, but it's pretty similar in concept, right? But it replicates all that chunks of videos to something called an edge network, and that is sort of it delivers the video to the user's phone very, very fast. Um, yeah, but there does need to be some pre-processing beforehand, of course, for the video resolution and file encoding. So it's similar to the upload stream, right? Of course, but we have to chunk the data because we're streaming. We're not just uploading an entire file. And we're also need very, very low latency as a requirement here.
I see. So is this? Yeah, Edmund, go ahead. Whoever just opened their mic.
Yeah,
Uh,
yeah. I'm reading. I've heard it, but I didn't really consider it because I was only thinking because of how short the videos were. Is it worth for the extra processing because you do have to do that replication across everything, right?
The extra processing of what?
For if you want to do edge computing, right? Like how does
Um,
Twitch do it specifically, right? Because I'm assuming they you're the producer, right, is uploading their stream, right?
mhm.
And it goes to whatever system that they use, right, to replicate it like across what like all local like it's a kind of like a CDN, right, near them.
Yeah.
Um, like what's do you need like that extra service really in this case?
Rather than
I guess I mean how long are the streams traditionally on TikTok, right? Because like Twitch is like much longer, like the average TikTok stream, right?
um,
I don't
That's
think
what I'm
they.
so
thinking of. Or is
I don't think.
are we in a case right now where we can say that they're both kind of the same length? We're assuming.
No, it's not gonna be like 5-6 hours, but I actually never used TikTok before, so I'm not sure how long the streams are. So, yeah, I'll be very curious. You know what you guys think that the should requirement should be here.
Yeah, because that's the only thing that like I can think of. That's the reason why that I'm a little like hesitant to going that far in.
So, Edmund,
Um,
is in your opinion, are you okay with the S3, or
I I like don't get me wrong. Like I think the edge network is fine. I just don't know if it's that's necessary for the case of TikTok.
mm-hmm.
Does that make sense? By the way, I'm not trying to shoot down your idea. I don't know who was saying that. Was it Umesh or
yep.
Yeah.
yeah?
No, I certainly see that. You know, I think there's not like a right or wrong idea. It's just like the point of this is like really discussing the edge cases. Like, oh, sorry, not the edge cases, the trade-offs. Like, what do we benefit from bringing on the edge computing? What do we benefit from bringing on the S3? And that's kind of the whole point of this,
Mhm.
is to really like deeply understand like what I'm hearing is that the edge computing will allow us to like have like a smoother connection. Is that the point of it? I'm so just really trying to understand here.
It's just it's a service for low latency videos, you know?
There's a blog on it on Twitch. I'll take a more proper look of it after. But this is something I'm going to note to
Yeah,
really
I
emphasize in the notes.
I think something I would love to see is like if somebody can do a system design session on Design Twitch, because I feel like it's
We
like
could do that for the next one. I'd be interested to do that actually.
yeah, I'm definitely looking for somewhere people to lead this type of stuff. It's pretty hard
Yeah.
to get ready for this and prepared, but I think it's really helping. But so yeah, that's pretty interesting. Mm-hmm.
Before we continue, Unmesh, if you have a specific blog or article about like Twitch's design that I can refer to, that'd be really great if you drop it in. I'm just looking at their engineering blogs right now, but if you have something more specific, I would more than happy to take a look at it.
Yeah, sure. I think it's a while ago, so I'll have to look.
Okay, thank you. Yeah, just whenever you can, man. Thanks.
So we can all agree that downloading the chunks uh, from S3 is going to be over UDP, right? So we don't care if if the file comes a little bit corrupted. Is that kind of fine? Sounds fine to you, Anmesh? Like no TCP downloading. Just like if we miss something, we just skip that completely.
Um, that would be nice if that was possible. I don't think that is possible.
So, well, I'm pretty sure that Twitch actually does use UDP for
Yeah, I know. Well, I think they use something else similar to UDP, but I don't think you can download chunks from S3 over UDP.
so
Maybe I'm wrong, but from what I recall, I don't think you can.
I guess then S3 doesn't become like a really good choice because like I want the video like to be like buffered and like even if it like blacks out for a few seconds or so, it doesn't necessarily mean that anything bad, you know. Like I'm okay with that, but to your point, you know, if we have one chunk that is completely un unreadable, you will not get any video at all. So I'm just not sure if like splitting this in chunks, you know, would work. So, you know, something I would want to do is that I would want to deep dive more into this. I don't think I have any expertise at all to kind of really have continued this discussion. We need to have a session, like design Twitch, design Netflix, that we can like even design YouTube. I know that they use like very interesting way how they like encode the video and how they like buffer it. So I think
That
yeah, I think we can live with this if nobody really has any questions.
I gotta drop for a bit. I'll join back.
Okay, cool. Thanks, man. All right. So, all right. How are you guys feeling so far? Feeling good? Feeling you guys need a break? Um, it's been an hour and a half since we started.
This is pretty good. How much more design or how much deeper do you think you could go? Like, what other aspects are there, major aspects?
That's a really great question. I think at this point we really don't we haven't really considered the numbers at all. You know, some of the things we've kind of looked at is that we didn't really tie back the numbers for the databases and how exactly that would affect the system. And like a really good like follow-up question from here is that we designed this thing to to have like video storage of 30,000 videos, and what I love to see is like see what changes I would need to make if this was a higher number. So kind of like identify the bottlenecks of the system. That can be like a really good discussion. Also, I think we talked pretty much about everything here. We didn't go much into depth about logging, sign up, and follow other users, and we didn't really talk much about like liking and sharing. But yeah, I don't think that there's much more depth we can go into. I think one thing we can really finally touch upon is kind of say that we have the discussion with the follower table. So that's something we can just spend like just a little bit more time discussing before I completely run out of ideas. But honestly, yeah, it's gonna be really hard to see exactly how notifications should be set up. So I don't really see myself going into much more depth. It's been, I guess, 4.5 hours since we started total. So it's been pretty wild thing, to be honest. Yeah, yeah. That's the only thing I can probably just um, say that this is our video upload API that we kind of discussed earlier that talks to this right flow, and we have our streaming begin stream API, begin stream API, and this begin stream API also does you know update the basically begin stream API goes back here Uh, yes, one thing we can also mention is this. There is another flow in this diagram that sends notifications, updates, and then send notifications to followers. So yeah. Well, yeah, but I think that's it. I don't really think that I can go in much more depth. I'm pretty sure other people would be able to, but yeah, I think I'm gonna finish up with TikTok right here at clean 4.5 hours total. Do you guys have any questions about anything?
I don't know if this is in scope or if anyone ever asked this, but what about the cost associated with the system? Like, how much time would it take to build? How many engineers do you need? What's the ongoing maintenance?
Yeah, that's a great question. I think I think the cost is definitely somewhat considered when you build a system. One thing I can mention that since we did chose an SQL approach for, let me actually bring this a little bit down and make the SQL table and all of this just a little bigger, so we can kind of more read from this. So something we talked about here is that once we choose an SQL database, they do come up with a more higher maintenance, and because the SQL uh, scaling is much harder. It requires much more application logic and requires partitioning or sharding on the spot, and requires it's more costly than doing a NoSQL solution. We talked a lot about like engineering experiences, and we didn't really consider cost of engineering, but this system definitely takes a good team, maybe like of two to 300 people to build, maybe over a few years or so, since we have like a lot of moving parts and not like really considering the UF GMLS, which is like a huge project just based on itself, the powering the recommendation algorithm and doing that. So the cost here is definitely very high. We could potentially reduce the cost by probably migrating to a NoSQL solution. That's something we can consider for sure. Yeah, I hope this answered your question.
So if maybe like 150 mil.
I guess it's hard to put a number out there. I'm not entirely sure. Yeah, I'm not sure this is like a like I'm not sure if you really need to come up with a number for like a system design interview. So yeah, I'm not exactly sure how exactly that would work out. But I think it's a fair question.
Yeah, not really in the spirit of the interview, just like curious to hear.
Not like just more curious. Yeah, I'm not sure. It depends. I think it too depends. Yeah, on the salaries and the market and how fast you hire. Yeah, I think if I was interviewing for a CEO, like or at least I was a CEO, I think I'd be able to answer that. But I think it's definitely beyond my pay grade. Cool. Any other questions? Everybody who's been listening for an hour, nobody has a question? Alright, then with that, I think we're pretty much done here. So let me know if you have any questions after the session, so we'll talk about it more offline.